All right, guys, last piece here. We've talked about our concentrations now and how we can measure our concentrations, right? Generally, we use molarity in chemistry, but sometimes we'll use some other units. What we're going to actually talk about is colligative properties, which is one of those times when we do actually use one of those other measurements, okay? So colligative properties for electrolytes, right? This is all based on concentration. Okay, so an electrolyte, right? This is a substance that produces ions when dissolved in a solution. Because the ions are free to move around, right? They're going to be dissolved in the solution. The solution is able to conduct electricity. Okay, so for us to conduct electricity, we have to move charges. Okay, so electrolytes do this by actually making ions. This is different than us conducting electricity in metals, where just the electrons are moving. Okay, but it's all about moving those charges. Okay, so what actually happens, right? We take a solute and dissolve it in a solvent. The solvent molecules, we've said, right, it has to surround the particles of solute. So it's going to pull those solute apart. It's going to cause our boiling point and freezing point to actually change, okay? So let's think about our water boiling, right? Water boiling, it normally boils at 100 Celsius. And if we think about it, right, we have our liquid water that's going to go to a gas, right? It's going to separate. So we can have our hands, right, acting like a liquid, and eventually they're going to move apart, right? But when I put some ions in there, all of a sudden I've got a pen in my hand, right? I am going to move more and more and more, but I need to try and separate even though I'm trying to hold this pen, okay? So I have to, right, it's harder for me to actually boil, right? So because those solute particles get in the way, the boiling point is going to raise, okay? The boiling point actually raises when you add some solute, right? So if we add salt into water, right, the pasta is going to boil at 102 or 103 Celsius rather than around 100, okay? Same idea here now for our freezing point depression, right? So freezing point, right, we've got a liquid trying to go to a solid, okay? So we can have our liquid, right, touching, and then to go to a solid, we have to organize it, right, organize those intermolecular forces to cross our fingers. But if I put something in the way, right, I can't really cross my fingers as well, okay? So if I can't cross my fingers as well, then it's not as easy to freeze. So our freezing point actually lowers when the solute is added, okay? So they go from their normal boiling point and normal freezing point and either raise or lower if it is boiling or freezing, okay? All right, let's look at the next sheet here. So, of course, we've got an example here, right? So we're going to start with the question, why do we salt the roads in the winter rather than sugar them, right? Why don't we just put sugar on them? Well, if we think about sugar, right? Sugar is sucralose, so that would be C12H22O11. It starts out as a solid. If I'm going to put it into water, right, it's going to become aqueous, but our ions, we don't have any ions in here. It does not separate, right? We're able to separate our particles, but they don't break down any more than this. So all we get is C12H22O11 aqueous, right? We get this aqueous solution now. So really, we only have 1 mole of our product. Now let's think about our salt. Our salt is NaCl. It starts as a solid, and if I throw it into water, our ions are going to separate. So we're going to have Na plus, that's aqueous, and Cl minus, that's aqueous. Now I have 2 ions in my product. I have 2 moles of my product. So what actually happens, right, the solute that dissolves to form a greater number of products, the more ions will have a greater freezing point depression and a greater boiling point elevation, right? If we create more ions, it'll generally increase this freezing point depression and boiling point elevation, right? It'll change by more. So let's think about CaCl2, right? We're going to make even more ions here because we're going to have Ca2 plus, that's aqueous, and 2 Cl minus ions that are aqueous, right? So we have 3 ions that get produced. But why don't we use calcium chloride? Yeah, you've guessed it. Because money, right? It costs a way more money to have CaCl2 rather than NaCl, right? So this actually, right, if we were to check it, right, NaCl lowers the freezing point, CaCl lowers it by even more, but CaCl2 costs a lot of money, okay? All right, so we're going to go ahead and we're going to look at the equations that we can use to describe this, okay? So again, colligative properties actually depend on the molality, okay? So we're going to have to use moles of solute per kilogram of solvent, okay? But then we can actually just use our freezing point depression and boiling point elevation equations, okay? So we have, for these equations, right, it's the change in the freezing point temperature. So it's going to be a constant times the molality. Boiling point, same idea, change in the boiling point temperature, a constant times the molality, okay? It really has to do with that concentration. So we're going to look here at a question, right? Number 2 here. What mass of I2 must be used to prepare 0.95 molal solution if 100 grams of methanol are used as a solvent? So what I can do, right, this is the same idea that I was showing before, but if we have 100 grams of methanol, that's the solvent. So we have 100 grams of the solvent. Well, I need, for my molal equation, I need moles of solute per kilogram of solvent. So I'm going to take my grams and convert it to kilograms. So 1,000 grams is 1 kilogram. And then I can use my 0.95 molal as a moles per kilogram conversion factor. So I have 0.95 moles of I2 per 1 kilogram solvent. Okay, so again, I can cancel my units all the way across to get my answer, okay? If I had that then and I had my number of moles or I had my 0.95 molal solution, I can also then determine the freezing point depression, okay? So this is a constant for water, so we wouldn't really want to use that in this question, but we can use these equations up at the top here, okay? So that's what we're going to be doing through these worksheets, okay? All right.